I'm delighted to be joined on Mobile World Live today by Dr. Daniel Twitchen. Daniel is Chief Technologist at E6’s. Daniel, it is great to see you. Thanks for joining us.
Thanks, Justin. It's great to be here.
So why don't we start, Daniel, by telling us a little bit about who you are and what E6 is, please.
So I'm Daniel Twitchen. As you said, I'm Chief Technologist of a company called E6’s. And at E6’s, we think we like to make the world brilliant using industrial diamond. And many haven't necessarily heard of industrial diamond, but basically E6’ does two key things. And the first is develop techniques for making scalable, production-friendly diamond. And in the early days, that meant making very small particles of diamond to a point where today it's possible to make wafers of diamond. Just to give you a sense of a wafer of diamond, that's what a wafer of diamond looks like. So probably very different to what people's perception of diamond is. And then in terms of making, it's one thing. But the other key thing is that E6’ does is work with our customers and partners to work out how to use that material to solve some pretty hard, challenging problems. And in many ways, since the very early days of industrial diamond, now more than 70 years ago, which when E6’ was founded, diamond's been playing the role of the disruptor, helping to enable new applications that we take for granted. For example, your smartphone. You're trying to make 1 million units a day. How do you make 1 million units a day? That's machined and touched by diamond. And very few of us will realize that actually every single day we touch something that's been touched by diamond. And a lot of that's been enabled by E6’ over the last 70 years.
Great stuff. I mean, perhaps tell us a little bit about some of the applications that leverage diamond technology that perhaps people aren't aware of.
So in terms of industrial diamond uses, those may be aware of the hardness and machining and shaping things. What people will be less aware of, a couple of examples, such as diamond is the best conductor of heat of any material. So you think about in semiconductor devices, 50% of the failure of electrical devices is driven by heat. Things get hot, things get cold, they break. The fact you have to recharge your electric vehicle often is partly because hot devices are less efficient. So if you can get a device cooler, it gives you two things, basically. It gives you performance and it gives you reliability. And diamond, the ability to make sort of this wafer scale diamond, where the diamond is at least 10 times better at conducting heat than existing solutions, gives the semiconductor industry a new option in terms of managing some of these real issues, which are increasing the bottlenecks of design and capability driven by heat. The second example I was quite like talking about, because I don't think we would have thought about it. It was actually just real wonderful innovation, is realizing your hi-fi unit, the bit that generates the high frequency part of the audio spectrum, people refer to as the tweeter. And you think about what makes a good tweeter. So it's high frequency. You want something to move very fast. So you'd like it to be very light. So you'd like a light material. And secondly, you want high quality, high fidelity. So you'd like that material to be really stiff. So if you like, the ultimate tweeter material is something that's both really stiff and really light. And believe it or not, diamond is the ultimate tweeter material. And today is already being adopted in home audio and actually car audio. So we're very exciting. That was, again, unlocked by some of these new techniques for making diamond.
Great stuff, Daniel. And let's look to the future as well. I mean, how is this material going to help support some pretty amazing technology developments that might be a year or two, perhaps further down the line?
As an engineer and a scientist, it's always a difficult thing predicting the future. And whatever I say, I'm going to get it wrong. But I think the thing and we at E6 are very confident of is, for the last 100 years, most people's awareness of diamond is as the girl's best friend. For us, diamond is an engineer's best friend. And I think the use and adoption of diamond across a vast end industry, diverse industries, will only increase over the next 10 to 20 years. The second thing I think is, and giving more specific examples, is up to now, diamond's been the thing that's helped enable other solutions. And what I mean by that is things like your smartphone you take for granted has in part been enabled by the ability to machine and manipulate materials to consistent with millions of units per day. I think the challenge and the opportunity for diamond is not just enabling other solutions, but actually being the solution. And giving you a couple of examples there, international governments, large companies, small companies, beginning to explore diamond for actually detecting magnetic fields. So believe it or not, it's possible to make a very sensitive magnetometer using diamond. And that magnetometer, for the first time, begins to enable you to look at things you couldn't do before. For example, detect signals that give you early characteristics of heart disease, magnetic signals coming from your heart. Navigation, if you want to navigate not by GPS, but by the variations in the Earth's magnetic field, these robust, sensitive magnetometers are being made in diamond potentially unlocks a whole new capability where diamond is the solution. I think the second area we at Element 6 are really excited by, and very much touches the semiconductor industry as well as municipal mass markets, is in the 20th century, we grew up on chemicals. Chemicals helped enable all sorts of things that we took for granted. We're increasingly aware of the legacy of those chemicals, and some of those chemicals refer to forever chemicals, or PFAS materials, a technical term. And these chemicals they were designed to be hard to break down. And guess what? There's now a mass of them in the environment, and increasingly awareness of how they impact birth defects and cancers in the body. There's a massive need to treat those. And there's a recent publication recently that said that Europe alone, this is a 2 trillion euro problem over the next 20 years. And recently, we with some partners, we actually showed the ability of using diamond to break down these forever chemicals and permanently destroy them. And I think that's a really exciting and important application for diamond over the next 20 years. So which wins and what actually happens is still to be determined. We'll see over the next 20 years. But what I'm pretty passionate and excited by is Element 6 will continue to try and work with its partners and new partners to try and make the world brilliant using diamond.
Daniel, that has been a fascinating insight into the role of diamond in technology, one we perhaps haven't heard too much about before. Thank you very much for joining us on Mobile World Live. Thank you.
Thank you very much.